Good morning. Why do we choose the tetramethylsilane TMS as a standard substance for recording the chemical shift? In order to measure or record chemical shifts, we need some standard substance. The choice falls on tetramethylsilane for the reason given below. It has 12 equivalent protons and thus gives sharp signals. Second, electronegativity of silicon 1.8 is lower than that of carbon. Consequently, the shielding of equivalent protons in tetramethylsilane is more than that of almost all organic compounds. Therefore, the signal of almost all organic compounds appear in the downfield direction with respect to the tetramethylsilane. Tetramethylsilane is chemically inert and possesses a low boiling point of 300 Kelvin. It can be easily evaporated after the experiment to recover the compound. What are the units for expressing the chemical shifts? Chemical shifts are expressed in frequency unit cycles per second. Frequency and magnetic fields are related to each other by the following equation: B equal to gamma S naught over 2 pi. Chemical shift expressed in CPS cycles per second is directly proportional to the strength of the applied field, which is in turn is equivalent to radio frequency used. Since different PMR spectrophotometer use different radio frequencies of 40, 60, or 100 megacycles, it is more appropriate to use units in which the radio frequency of the instrument has been cancelled out. This is done by dividing the shift in CPS by the radio frequency employed and multiplying by a factor of 10 to the power 6 so that shifts are obtained in parts per million. If a signal is obtained at 120 CPS downfield with reference to tetramethylsilane using 50 MCPS, 60 into 10 to the power 6 CPS, then the chemical shift is given by chemical shift 2 ppm. There are two scales of expressing the chemical shift. These are the delta scale and tau scale. Both of the are in parts per million. Delta equal to delta V in CPS 10 to the power 6, radio frequency used in CPS. Where delta V signals is obtained, radio frequency used that is reference to TMS using tau 10 minus delta, taking the position of the tetramethylsilane signal at 0 ppm. Most chemical shifts have values between 0 to 10. A small value of delta indicates a small downfield shifts, whereas the large delta value indicates a large downfield shift. On the tau scale, the position of TMS signal is taken as 10 ppm and most compounds have chemical shift values between 10 to 0. This explained with the help of the flowing diagram. Tau scale 10 to 0 and delta scale 0 to 10. Explain the various signals in the PMR spectrum of benzyl alcohol. This is the benzyl alcohol. The number of signals in the spectrum tells us how many different types of protons are present, and the position of the signals tells us about the nature of the different protons in their environments. In the spectrum of benzyl alcohol, shown above, we observe four signals which are due to protons as detailed below. The small but sharp signal at delta equals 0 is the reference signals of TMS. Signals at delta equal to 7.3 is due to 5 equivalent ring protons. The signals at delta equal to 4.6 is due to 2 chemically equivalent methylene protons. The peak at delta equal to 2.4 is due to hydroxyl protons. Okay, it's all about some questions related to NMR. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you.